Today, we're going to learn about polygons. We see a variety of shapes around us. Some of these are represented here. Can you tell me which of these figures are closed figures? Think a little. Let me explain this. By looking at these figures, the first thing we observe is that some of these are made of closed curves, while some are made from open curves. If we focus only on closed figures, then there is an interesting point for these. Among these figures, some are made of line segments only, whereas some are not made of line segments. They are made up of curved lines which are not straight. We call figures made of line segments as polygons. If we break the word polygon, we get two words, poly and gon. Poly means many and gon means sides or angles, which means a figure that has many sides is called a polygon. Now assume you've been given a pencil. Will you be able to make a polygon out of that without breaking it? Think a little. No, because a line segment cannot form a closed figure. Similarly, if we take two pencils and try to make a polygon out of them, then again we will not get a closed figure or a polygon. But if we take three pencils, then we can definitely make a polygon. Similarly, we can make polygons from 4, 5, 6, etc. pencils. In this way, we can say that 3 or more than 3 line segments are necessary to draw a polygon. Such line segments which form a polygon are called sides of polygon. Therefore, a polygon has 3 or more than 3 sides. The point at which any two sides of a polygon meet is known as the vertex of the polygon. Here, we will name the vertex as A. Similarly, we can name the other vertices also. In this way, we can say that this polygon has 4 sides, which are sides AB, side BC, side CD, and side DA. We can name a polygon with the help of its vertices. Like here, we will name it as polygon ABCD. While naming a polygon, remember that we start from one point and move to the other subsequent point in an order on the boundary of the polygon. This order can be in either clockwise or anti-clockwise direction. Like this, we can name a polygon ABCD or polygon BCDA or polygon CDAB, but we cannot name this polygon as ABDC because points ABDC are not in sequence on the boundary of the polygon. Now let's talk about side AB and side BC. Both these sides are meeting at one point only. This means for side AB and side BC, point B is the common point. Any two sides having a common endpoint is known as adjacent sides of a polygon. Therefore, here sides AB and side BC are adjacent sides to each other. So, can you tell me which are the sides adjacent to CD? Think. Absolutely correct. Since D is common in sides CD and DA and C is common in sides CD and BC, therefore, DA and BC are adjacent sides of CD. Now observe side AB. This side has two endpoints, point A and point B. The endpoints of the same side of a polygon are called adjacent vertices. Therefore, point A and point B are adjacent vertices. Similarly, point A and point D are adjacent vertices. But point B and point D are not adjacent vertices. Can you tell me the reason for this? Absolutely true. The reason behind this is point B and point D are not the endpoints of a single side. If we connect such vertices which are not adjacent, then the line segment so formed is called diagonal of the polygon. Like here, line segments BD is the diagonal of the polygon. Similarly, if we connect A and C, then we get the diagonal AC. In this way, you must have understood a lot about the concepts of polygons. Today, we have learnt about polygons. In the next video, we will see some interesting examples of this.